Hello, welcome to my channel. We are still continuing the tutorial on the topic probability, and we are taking a compound event in this episode. If you are new to the channel, consider subscribing, like, and share. Now, under compound event, simply put, combination of two or more events, whether they can occur together or may not occur together. So combine. But in this, we are going to marry them with some various terms, as is mutually exclusive, independent event, and dependent event. And then how do we combine these two or more events? The combination is done using the word or and. So these two words will be used to combine the two or more events. So in the case of or, it is also corresponding to union. Set theory. If you use the union, combination of two set or more set together, then and is also correspond to intersection, meaning the two sets have something in common. All right. So or is used to combine two or more elements, and is also used to combine whether they occur together or may not occur together. If you use union, you are referring to the or. At times you will not see the union in the question, but in the wording of the question you will hear the word or, meaning you are combining. You may also not see intersection, but in the wording of the question you may hear and. Now, mathematically, how do we put this together to solve questions under probability? If we are seeing or union, we are going to be using the addition, that is the addition law. Then, if we hear and, which means intersection, we are also going to use multiplication law. So this is multiplication if it is intersection, addition if it is what? Union. So for example, if I have event A and event B, if I'm asked to find their probabilities using this, so probability of A union B, which means that probability of A or B, meaning the union. So if I'm referring to union, which also means addition, it is going to mean that probability of A union B will be equals to the probability of A plus the probability of B. If we are talking of union, if I'm using the word or, A or B, I am adding the individual probabilities. All right. In the case of and, then it will be probability of A and B occurring together. So that will be probability of A intersection B. So A and B means intersection, and we are saying that is under multiplication. Therefore, this could be written as probability of the A times the probability of the B. So under combination, we are saying that we are combining the event using either and or these two words, which also means union and intersection, which extensively also mean addition and what? Multiplication. Now, in the beginning, I mentioned of mutually exclusive, independent, and dependent. All these can also be used on this. So if we are saying two events are mutually exclusive, simply means that the events cannot occur together. The two events cannot occur together. It means they are mutually exclusive. Now, so if we are talking of mutually exclusive event, it means that they cannot occur together. And under set theory, if two events cannot occur together, it becomes a disjoint set. Meaning, if I have this, A and B, if they cannot occur together, occurring together will mean that they can have intersection. So since they are not occurring together, it means that a disjoint set, meaning they are intersection. If I want to use this, number of A intersection B will become what? 0, or better still, empty set. So under mutually exclusive event, there is no intersection. So if we are going to talk of a set theory which make use of number of A union B equals to number of A under set, De Morgan's theory talk of the number of union equals to the sum of the individual set minus the intersection. But if we are saying the set are mutually exclusive, meaning there is no intersection, meaning this subtraction become what? 0. So I'll be dealing with union equals to the sum of the two individual terms. That goes for our first compound event that I'm talking about. So this being the first one, using the OR. So if you are referring to OR and the mutually exclusive, it is just probability of the first one plus the second one. Okay, so that is for the OR. Now under independent event, when the events are independent, that also means that the occurrence of one event does not interfere with the occurrence of the second one. If there are two events, the occurrence of one does not interfere with the occurrence of the second. That is what you have independent. So if the two events are independent, then we are going to say that their intersection is going to be multiplication. So if they are independent, then we multiply their individual probability in terms of intersection. Alright. Then we have what they call dependent. If the two events are dependent, that simply means that there is a probability of what? The occurrence, interference of occurrence in the first and in the second. If that occurs, then it means that there will be intersection. They are dependent. So the occurrence of one may have something to do with the occurrence of the second, then there may be intersection. In that case, our OR, which is a union, the use of union becomes the probability of A union B equals to probability of the A plus that of the B minus probability of A intersection what? B. While the A intersection B is still talking about the independent event, which is the multiplication. We know multiplication and intersection. This. So we can find this using the multiplication, which is this. Then we already will be given the probability of B and the A. Then this will show that the probability is not, the events are not independent, but they are dependent. And better still, they are not mutually exclusive. If they are mutually exclusive, the intersection becomes 0. I believe the concept for these three terms is explained, and the combination terms is also explained. Let's see how we can employ this in a question. So a fair die is thrown once. What is the probability of obtaining a 4 or a number greater than 4? So we can see that we are combining the event. It is two events that is occurring. So obtaining 4 and obtaining a number greater than what? 4. We are using the word or. So first of all, we know probability deals with sample space and event. So let's take the sample space. So if we let our U equals to the set of dice, which is going to be 1. So these are the numbers we can see on the die. So number of union become what? 6. So now we need to repeat our event. So event of obtaining 4. So let E equals to the event of obtaining 4. You see, in this set, you can only obtain 4 once. So that will be 4. So number of event E become 1. We have only one trial, as we can see there. So if we know the event, we know the sample space, finding the probability will not be a problem. So the probability of the event is going to be number of event over number of what? Sample space, which is 1 out of what? 6. So 1 out of 6 gives us probability of this. Now, the second combined, a number greater than 4. What will be the event? So let's use D equals to numbers in this set that is greater than 4 will be 5 and what? 6. So what will be the number of D? It will be 2. So probability of D now becomes number of D over the sample space, which will be 2 out of 6 as 1 out of what? 3. So now we know the two probabilities has been known, but we are combining them using OR, which means probability of E or D, which also means that probability of E union that of what? D is going to be the probability of E plus probability of D. In that case, we can also, let's introduce probability of E intersection that of D. But if we check here, the set is from 1 to 6. If we check here, the set is only 4, as we can see. If we check this, it is only what? 5 and 6. If we are going to go for intersection, we need to have an overlap of the element here with this element. So this means that the two events are mutually exclusive. The two events are mutually exclusive. They're not dependent on each other. So we can't get intersection. It means this will be 0, since there is no element here that found itself here. So we are only going to add the two individual probabilities using the word OR, as we are having in the question. So this becomes 1 out of 6 plus 2 out of 6. This is the same as this. We have the same denominators. So we add 1 plus 2 over 6, and that is 3 over 6. 1 out of what? 2. So simply put, the probability of obtaining 4 or a number greater than 4 is just half. That's 1/2 of the whole trial or the whole experiment. So this is how we talk about compound event. It could be union, it could be intersection, it could be independent, it could be dependent, it could be mutually exclusive. I believe concept well explained to your satisfaction. If you like this video, find it educative, don't let it sit with you. Share with somebody who may need this on your contact list. Let them subscribe. Click on notification bell to receive notification anytime a new video is uploaded. Subscribe if you are new, comment and like. Bye-bye.